In this video we're going to take a look at some of the reverse engineering challenges on the Angstrom 2021 CTF. So I'm not too sure how many challenges I'll get through, but you can skip between the challenges using the timestamps in the description or at the bottom of the video, the chapters. And any scripts that we create throughout this will be uploaded onto the GitHub as well, so the link's also in the description. So I hope you enjoyed the video. If you do, drop a like, subscribe, and we'll get started with this free flags challenge. So the description says, Clam was browsing ångstromCTF.com when suddenly a pop-up appeared saying get your free flags here, along with a download. Can you fill out the survey for free flags? So we're given a link to the binary. We don't have any source code like we did in the binary challenges, and then we're told we can connect to the Netcat server or use the shell server once we've got it working. So we can download this file. I've already downloaded a copy of it into the local directory. So if we have a look here, it's a 64-bit LSB Pi executable. And although it's not a binary exploitation challenge, we might want to have a look at the security protections that are enabled anyway. And we'll see that everything is enabled. So let's try and run the program, see what happens. We get this congratulations message and we're asked, what number am I thinking of? So let's try and put in a number, something that might be like leet, and we get wrong. So if we try and run that with ltrace, sometimes if there's a string compare being done here, we'd be able to enter in an input and we would see what it's actually being compared to, but we don't in this case. Let's have a look at the strings as well, just in case we have the expected input sitting in here somewhere. So we see there's the flag.txt here. This is the input here. It's asking what number am I thinking of, but we don't have any other string here which is indicating what we need to enter. So let's go and let's create a new Jailbreak project, and we'll be able to go and have a look at the assembly and the decompiled code as well and get a better idea what's going on. So we'll go here and create a new project, free flags, and then we want to import the file. And then if we double click that to open, and we'll get another check, just hit yes and OK to analyze all the default analysis checks. And then because this isn't stripped, we'll be able to go straight into our functions here and find the main function. You can see we also have this print flag function as well. So if this was a case of the flag being in the program, this might be a function of interest, but we know that it's going to be reading from a flag.txt. So whenever we're running against this against the server, yeah, we need to work out what's going on in the main function. And we can see that it asks us what number am I thinking of, and it's comparing the input that we provide, this local 11C, against this value here, which we can have a look at the hex. If we just go and highlight it on the the disassembled code on the left, we can highlight that and see that actually equals elites, so 31337. So if we go back and run the program again, this time pass in 31337. This time we get another question, what two numbers am I thinking of? So we could try some input just to see what happens. We get wrong again, so we need to go and have a look what's happening in the code. So it reads in two numbers off us, 120 and 124, and then it's doing a comparison to say if we add these two numbers together, do they equal 1142? And if we multiply the two numbers, does it equal 302,937? So to work this out, I just went to, let's look for, we want to find out what are the factors, and then we can go and see which one's going to be best for us. So let's just go to the first link here, and the number we want to look for is, I believe 302,937. So we'll go 302,937, calculate, and then we have some different possibilities. So we could go through and we could try some of these out. Essentially, we need to find which two of these, when added together, are going to equal, was it 1,152? 1,142. So we could just go and try. There's not too many to try. We could actually just go and try them in the program, or we could add these together. Let's go over to the program again, and we'll do 31337, and then what are the two numbers? Let's say the first one is 241 and the second one is 1257, and we get that's wrong because those two added together isn't going to equal 1152. So it's likely to be then our last possibility there. So let's go 31337, and then we'll try 419 times 723, and this time we get then what animal am I thinking of. So let's go back to our code, and you can see it takes an input off us as a string, and then the string compare is being done here with banana. So we could actually, if we were running this in ltrace, this should give us, in fact let me do that, let's do ltrace./free flags, and the first one is 31337, and then 419723, and then if we get to our final one, let's just make up, let's say okay, monkey, and you'll see there it's compared monkey to banana and has said that's wrong. So if we go back and do it correctly this time, 31337, and then 419723, and then banana, you can see that it's tried to open the flag but it couldn't find the flag, so we've now got a correct input. So if we go and enter in these same values onto the server, then it should print out our flag for us. So I created a script already to automate this, Pwn Tools script. So if we open up exploit.py, and essentially here we're just waiting until it asks us what number am I thinking of. We give it 31337, we give it the two numbers that it's thinking of after that, then we give it the banana string, and then we get back our flag. So if I try and run this, if we run it locally we get that could not find flag file, but if we now just pass in remote, let me minimize this to make it a little clearer. If we just pass in remote, and let's go back to get the server address and port number, paste that in, and it sends it off, and this time we actually get back our flag. So now we can just take a copy of that and submit it, and we got the first challenge. The second challenge is called Jailbreak, and the description says Clam was arguing with KMH about whether including 20 Pi jails in CTF is really a good idea, and KMH got fed up and locked Clam in a jail with a Python. Can you help Clam escape? So we're given a file here to download, and we're told that we can use this address and port once we've got it working locally. So I've already got the file downloaded. Let's go and take a look at it. And we, as usual, we'll check the file type. We'll see it's a 64-bit LSB Pi executable, so Pi is enabled and it's stripped, which means Pi means each time the binary loads is going to have a different address. So if we're setting up breakpoints, we're going to need to use the offset from the base, and then stripped just means that debugging symbols have been stripped from it. It's going to be a little bit harder to statically analyze and reverse engineer, but shouldn't cause us too many problems. We can try and run strings on it as well, although with it being stripped we're not going to see too much. We've got a string, what would you like to do, and that's about all. So let's try and run a program, see what happens. And we get welcome to Clam's Dare and Jailbreak, please keep your hands and feet inside the jail at all times, what would you like to do? So we can enter some commands and we just get you're speaking nonsense, cut that out. Let's exit this and run it again with ltrace and try and see what kind of string comparison it's doing there. So it's asking what would you like to do, and it's calling in our input with fgets. Just say hello, and it's comparing hello to look around, to sleep, to knock on the wall, to pry the bars open, pick the snake up and throw the snake at KMH. So these are our different options that we can run through. Let's try and look around. Look around, we get a message back. KMH stares at you wondering how to make the jail cell more contrived. We can sleep, and this gives us a message saying we get bitten by the snake, and then it exits. So let's run it again. Let's just get the commands back up. The next one was knock on the wall, and if we do that again we get a message, shouldn't have blatantly ripped off Pico's challenges. We can pry the bars open, and this exits as well, saying that KMH decided to patch the universe interpreter to make the bars immovable. So what else do we have? We can pick the snake up, and that's it. Oh yeah, we picked the snake up and then it just loops back round, and we can throw the snake at KMH. and then it just comes back saying what would you like to do, or he runs in fear, what would you like to do. Okay, so there are all our different options. Notice that although this says it's a PyJail, there's no Python source code, and it seems to be a Python related story, but doesn't seem to have any Python code. Obviously this is an executable file, and Python doesn't generate into an executable, it's a scripting language. So we're going to open this up in Geardra to have a look at the source code. So we'll create a new project here. This is a little bit of a slow process, so I'll speed some of this up. And now we get to our project. We have our decompiler on the right, our disassembled code here, and then we have access, we can see all the different sections here of the program. We can go and have a look at our functions, although in this case we're not going to have a main function because it's been stripped. You can see these have all been kind of randomly named, so we could just go through and have a look at them, see what each does. We could have a look for the strings in the program and try and find any that we see whenever we run the program. However, although whenever we run the program we get this message, and we did see a string in whenever we ran strings, we don't actually have anything here to go by. So that's fine. What we can do is just have a look for the entry function, and then we'll select the entry function and have a look at the first function that's called, and then we'll see quite a lot of code here. This is clearly the conditional statement that we've been getting, asking us for different commands. You can see there is a lot of code here and it's quite obfuscated, so we need to go through and try and work out what's going on. Now note that in my first attempt at solving this, rather than try to decipher exactly what was going on with all these conditional statements and what conditions we needed to meet, I essentially looked at this function. So you can see that on all these different conditions, this function is being called with a different parameter. So if we go in and have a look at the function, and we can see that there's some kind of XOR operation happening here in a loop. So the function that's being passed in, the int param1 unsigned int, is being used here to define an area of the .data section. So if we go and have a look at the .data section, it has a lot of different hex values in here, and this is one of the strings that we got. So we can see that it's reading in based on whatever parameter it's given. It's gonna define a section of this .data section to read from, and it's also using this parameter in the loop as well. So it looks like it's looping through some data that it finds here, and on each loop it's going to set the param1. So in this case, in this example, let me go back. This was given, okay, 0x19, we've got 0x1a. So depending on what this is given, it's then going to multiply this by hex 11, so 16 times 1 plus 1. And the value is going to be used here, ivar3 is used down here again when setting the value of param. So we're XORing this bvar1, which is being grabbed from the .data section. So we're looping around, grabbing, I guess, a byte and or a value, a character, and we're XORing it with the param1, and then we update the loop. We update param1 to equal the XORed value from read from the data section, XORed with the parameter, and then multiplied by the parameter plus ivar3, which was the previous. I don't know, is that updated here? Ivar3 is param times 17 or hex 11. So it's going to go through, it's going to do that each time, and then the result is brought back. So my initial thinking behind this was, well, if we can recreate this loop, or if we can set this up whenever we're debugging that so that we can pass in these different parameters, then we might not ever need to work out exactly how these functions are structured and how this code is structured. If we can just call this function and pass in these different values, then we'll be able to allow the XORing to be done against whatever's in the data section. My thinking was, well, maybe there's a password, there's more commands in there which will allow us to escape the Python jail. So before I demonstrate how I solved it, let's see how I kind of went about it to begin with. So if we go back to this function, although we don't have the address because Pi is enabled, we can grab the offset of it and use that whenever we're. Let's open up GDB pwn debug. So we can't set the breakpoint here straight away because until the program's running, because pi is enabled, and also if we have a look at the functions here, we're only going to get our libc functions. You can see based on the addresses, these are all just offsets at the moment. But if we start to run the program and then Control and C to get out of that, now if we have a look at our functions, we're going to see a lot more there. And also now we can set up our breakpoint. So we can have a look. If we do pi base, we'll find out this is the base that the binary loaded at. So this base plus any of these addresses will give us an offset. So in this case, the start of this function is 15A0. So you could do pi base 0x15A0, and that'll give you the address of this function. And we can do that in Pwn tools and stuff as well. But we can also use break RVA. So if we do break RVA help, this will allow us to just directly set up a breakpoint at the pi base, and we can again give it an offset. So I'll just go back here and change this to break RVA. And now every time this function is called, it's going to break. So we could give it a parameter here, or I'll just hit enter in this case. You can see that here we go, this is the instruction that's being called at the moment, which is the beginning of this function. You can see in the background, hopefully you can see that, but in the background we have the move xd rax edi, which is happening at the moment, and the parameter that's being passed into the RDI is the number. So if we go back here, what's being called at the moment then is this. The function is being called here, it's being passed in a 2, or it's being called somewhere else and being given a 2, maybe here. So if we go and modify the value that it's being given, let's change it to, for example, and the way I chose which values to start off at here was without looking at the code too much. We can see here we have this value ivar7 equals 539. So if we go and have a look at that, that's 1337 leet. So it's pretty clear this is going to have something to do with the conditions we want to meet. You can also see here that it's opening up a file and it's reading in from the file and is going to put that value out. So it's very likely this is where we're opening the flag file, we're reading it in, and then we're putting it out to the screen. In which case this is going to be of interest to us, and we know that we need to meet a couple of conditions to get in here. So we're going to need at some point ivar7 to equal leet. We're going to need ivar3 not to be 0 here. We're going to need ivar7 not to be 0. So if we go and have a look, ivar7 is initialized to 0. And we could go through and have a look and see where is it assigned. So here it's compared to leet, and it was we made sure it wasn't 0 before that. If we go through, we also have it being assigned a value here, but this is all inside this code block. So first, ivar7 needs to not equal 0 in order to even get into this section, so that's not really going to count for us. And then we also have it again here, it's being used directly below that, but again that's inside the same code block. So we have ivar being set to 1 here in a different part of the code, and that's the only other place that it's assigned a value. So at some point we're going to need to go and have a look and find out why what conditions we need to meet in order for that to be set to 1. But for now, let's just continue with this. We currently have the function being called with 2 in, but we can go and swap that 2 out now with a value. So let's say we know we want this to equal leet, and whenever it does equal leet, it's going to call that function with 0x17 in there. So let's go back to GDB and let's set our RDI to equal 0x17. And then we can continue, and we're going to be waiting for the string compare to happen. Notice that the RDI has been overwritten there, so I'm just going to change that and continue until we get out our string. And there we've got out our string Bananarama. So that wasn't a string that we saw coming up before, so it might be something as well that we might want to try and just go and run the program and enter it in, but we don't get anything back. So we could try that again. If we go back into this, it's going to the 2 again, so that's also an indication to us that the program this is the first comparison it's being done, so it's being compared to 2. It looks like it's then going to compare it to 6, it's going to compare it to 9, and they're going to be our various options then that are given to us: look around, sleep, knock on the wall. So we might want to go and rename some of these functions as well to some of these functions or some of these variables to show what they represent. But for now, let's I basically went through this and I went and compared this to each of the different values. So here we have the 1, 9, we have the 0x1a. Running those, I believe this is where we're opening up the flag file. So we have our flag.txt and then the R parameter. Let's have a look at some of these. We have the 0x13 and 0x14. Let's check out one of those. So I'm just going to set this to 13. I should be able to set a breakpoint up at a better place here really, but I'm not going to do this too many times. And this is press the red button. If we check the other one, it'll be press the green button. And essentially I went through and mapped all of these out. I was kind of hoping when we got to points like this that now that we've found a new command, we might be able to just run jailbreak and then say press the green button or press the red button, but we don't get anything. We didn't get anything from doing those steps. So at that point I was forced to actually go and take a look at this code and try and work out what conditions need to be true. So we know at first we need to get ivar 7 not to be 0. It's assigned 0 at the beginning and it's only assigned a value down at the 1. So we need to get this condition to be met. So we could go and set up a breakpoint here to try and identify when we get to that. For now we can just trace this back. So in order to get ivar 7 equal to 1, we need this condition to be false. We need bvar 1 to be false, because if it's true it's going to go to call this function and then it's going to jump down to 13C8 wherever that is. So we need this to be false. We need ivar 3 to be true, be 0, which is the string comparison. So we need the string comparison here to be true, and the string comparison is the result of calling that function with 0xb. So if we just go through and look at these, we have our look around, which was 2, we have sleep, which is 6, we have knock on the wall, which is 9, and we have pry the bars open, which is 0xb. So we need to pry the bars open in order to get this to be 0, and then we need bvar 1 to be false in order to get ivar 7 to be true. So we could go ahead and we could set up a breakpoint here. Let's set up a breakpoint and confirm that we'll get to our, not a string comparison here, we know that this will hold true as long as we get the string comparison true. So let's set a breakpoint up around the bvar 1 and see what this is set to. So we'll set a breakpoint at 12D9 at this test, and I'll delete the breakpoints we have at the moment. Break RVA 0x, can't quite see that, 12D9. And now if we run the program, and if we were to try and put in, we need to pry the bars open, we know that's 0xb, which we need to match there. So if we were to try and put something else, let's say pick the snake up, then it's not going to hit the breakpoint. We need to try to pry the bars open, and then we'll hit the breakpoint. It's getting to test R13, and let's actually set up a breakpoint as well at our ivar equals 1 is 12E7, so we could break RVA 12E7, and then we can just continue and we'll see that it escapes because we didn't hit that breakpoint. So we need to go and try and find out why our bvar 1 is currently true, because that's calling this function 0xc. 0xc contains, I believe that'll contain the message that the error message that we were just given back, or that you start prying the prism bars open. So we're being told that the prism bars can't be opened, so obviously we need to make sure that this equals false, and then we will be able to open the prison bars. So again, we can have a look at bvar1 and see where it's assigned. So it's declared at the beginning, it's assigned a value of true, and here there's a comparison done, another comparison. So here's where it's assigned false, 10144E. And in order to get to this code, we need to get to this part of the else statement. So it's going to check if cvar2 equals \0 or cvar8 equals \0. It's not going to get down to the code we want to get to. So we want to make sure both cvar2 is not equal to \0 and the same with cvar8. And cvar2 is going to be assigned here, so it's going to call here it's calling pick up the snake 0xf, and this is calling throw the snake, which is 0xe, which I just have noted down from doing the XORs earlier. So that's going to take care of cvar2, but if we have a look at cvar8, we can go through and find this. cvar8 is assigned a value once we get to this code segment. That's not too much good for us. It's checked down here, and it's also assigned down here as cvar2. If we go back to the top, we'll see that it is assigned \0 at the beginning. So we do need to. The only other place then we can make sure that that is assigned a value is if we get this code to execute. And this is part of this else statement. So we have, where is our if for this? We have if. So this is our menu option where we had our pick up the snake in this case. And remember, we have our other options here. We have look around, we have sleep, we have knock on the wall, pry the bars open. Here we get to pick up the snake. So if we choose to pick up the snake, it's then going to check the throw. It's going to check to throw the snake if throw the snake's been called. Otherwise, if we don't do that, it's going to try to throw the snake. So if it does get down to this section, it means we've tried to throw the snake, and if we try to throw the snake, it's going to check if cvar8 doesn't equal \0, which it will equal \0 because we've not had any method of reassigning it so far, which means this code wouldn't be executed. It would execute the bottom code to reassign that. Hopefully that makes sense. I think I went through this with a lot more breakpoints whenever I actually solved the challenge, which probably helps. But essentially, we need to pick up the snake. We need to throw the snake, and then that will get us into this code block and set bvar1 to false. Once bvar1 is false, we know that we need to call 0xb in order to assign ivar1. So we need to pick up the snake, we need to throw the snake to get bvar1 to equal false, and then we need to pry the bars open to get ivar7 to equal 1, and then whenever the loop goes round again, it will finally be into this code segment. So let's set a condition around here, our ivar7. So 1197, let's go back and set up another breakpoint. I'm going to close this down and just start it up again. We'll run and we'll set break RVA 0x 1197. Let's actually go and set up some more breakpoints as well. So we have our ivar7. That's a condition we want to meet. We want to make sure it's not 0. We also wanted to make sure bvar1 was equal to false. So where was the bvar1 assigned again? Let me find bvar1. bvar1 is assigned false right here. So whenever this is called 144E, that's going to be assigned to false. We'll set it at we'll set it right there, and that's 1459. So let's try and run through some of these. If we hit continue now, we want to try and pick up the snake. Let's actually try the other way around first of all. Let's try and throw the snake at KMH. So we've hit a breakpoint, And that is our comparison, so it's checking if IVAR 7 is equal to 0 right here. So if we go back and have a look at that, R12, it is equal to 0. We want to make sure it's not equal to 0, so we hit continue and we get "you're speaking nonsense, cut that out." So we're not actually able to throw the snake at KMH at all anyway until we've picked up the snake. Let's hit continue again. "You're speaking nonsense." Yeah, okay. So let's try and pick up the snake. And now we get to our breakpoint again. We still don't have R12, it's still 0, so that condition is not going to be met. And now we can try and throw the snake at KMH. We get to our breakpoint again, R12 is still going to be 0, but now if we continue, and we don't hit our breakpoint for assigning bvar1 as false. Let's try anyway and pry the bars open. And we get back to our breakpoint here, which is testing to see if that equals 0. And in this case, okay, so we tried to pry the bars open, we got the exit there. So the issue was that we tried to throw the snake, I guess, before we pick the snake up. Let's just try that one more time. Throw the snake at KMH. I'm going to continue, and then we'll try to pick the snake up. Continue. Throw the snake at KMH. Continue. Okay, I don't know what I did wrong last time. Maybe I didn't get the order right there. So yeah, this time we get the XOR. So that's the condition we expected to be true. So it doesn't matter if we try to throw the snake before picking it up, as long as we at some point pick the snake up and then throw it in that order. And in which case we've just hit this breakpoint. bvar1 is now equal to false, which means that whenever we enter the 0xb, which is pry the bars open, it's going to get down to this check and say if bvar1 is true, which it isn't because we've just assigned it to false. So it's going to then jump down and set ivar7 equal to 1, which means the next time this loops round, well, not the next time, but after we've done pry the bars open, this condition should finally allow us to get into the code segment that we're interested in. So are we at a breakpoint? Continue here again. This time we want to pry the bars open, and we've stopped at a breakpoint here. We have R12 is still equal to 0. Let's continue, and you stop prying the prison bars open. A wide gap opens for you to slip through. What would you like to do? So in this case, let's try and just enter. Can I just enter another? Just enter another command. We get back to our loop, and this time R12 is equal to 0x1, which is exactly what we wanted. So let's actually, rather than continuing, let's go next. And it is going into the comparison. It actually compared there with look around. So let's go back into our code, and you'll see that if ivar7 is not equal 0, which it isn't anymore, it then calls this function with 2, and 2 is equal to look around, and then it's going to set ivar3 to equal the value. So because we didn't enter look around there, that's not going to be true, which means whenever we get to this section, it's not then going to go through and check if ivar7 equals 0x539. So what I'm going to do is I'm going to go set up a breakpoint right here as well, 11cc. In fact, let me delete breakpoints, and we'll do break rva 0x 11c. Was it 11c3? 11cc. We'll set up a breakpoint there, and then I'm going to run the program again. We're going to need to enter in our usual commands. So let's first of all pick up the snake. I'm just copying and pasting this now. We're going to throw the snake, and then we're going to pry the bars open, and now we know we also need to look around. And now notice that we've got a string that we haven't seen before. You look around, you see KMH has already made the jail contrived. There's a red button and a green button with a sign that says press buttons to get flag. So this is where we can start entering our new commands. Press the red button and press the green button. So let's press the red button. We hit that and now we get to our breakpoint. Our breakpoint is doing this comparison. It's comparing R12 to 539, which we know is actually equal to leet in decimal. So we can see that there. And it's comparing R12. R12 is currently equal to 1. Okay, so not much use. We'll hit continue. What would you like to do? Nothing changed. Let's press the green button. And you'll see we've got back to our comparison. It's comparing to its elite, and this time we've got 2 in there. So let's continue again. Press the green button, nothing changed. Okay, so we're just in this loop, and let's try and press the green button again. And you can see now our R12 is equal to 5. So whenever we're pressing these buttons, this R12 is increasing. So let's go and have a look at the code and see what's going on. And we could set up some breakpoints here because I've already got in my notes, I already have what all these values equal when XORed because I went through and did that manually whenever I was solving it. I know that 13 is press the red button and 14 is press the green button, so we could set up some breakpoints around here, or we can just have a look through and see what the code's doing. And essentially we'll see that IVAR 7 is being assigned to IVAR 7 times 2 here, and in this case IVAR 7 is being assigned to IVAR 7 times 2 plus 1. So we know that IVAR, whenever we get into this loop to begin with, IVAR 7 is equal to 1. We need IVAR 7 to equal 539 in hex, which is leet 1337. And we can do that by pressing the green button and pressing the red button. The green button is 14 and the red button is 13. So every time we press 13, it's going to double our value. Every time we press 14, it's going to double and add 1. So we know IVAR is going to start off as 1 once we've pressed the right values, and then we can go through here. Let's go and open up a calculator, and we can do this in reverse. If we start off with 1337, because this isn't going to evenly divide by 2, in this case we would be subtracting 1 and then dividing by 2, so that's the green button. So we could say here green, this is how I kind of did this earlier. And then because this is an even number, we would divide by 2. So then it's going to be the red button. We need to put that before the green. And again, an even number, so we would divide by 2. And again, it's going to be the red button. Before that's going to be the green, because we can now see we have to minus 1 and then divide by 2. And essentially go through and do that process. I already calculated that out earlier on, so we'll just go ahead and test it out. So we have our breakpoint set up at this comparison, so I've already got these written down. We'll go back and test it out. Let's continue here, and first we want to pick up the snake as usual. Next we want to throw the snake, and we can see that he runs in fear. We now want to pry the bars open, and a wide gap opens that we can slip through. Now we want to look around. Look around, see that the jail's already contrived. There's a red button and a green button, and now we want to stop pressing the buttons. So we're going to start by pressing the red button, and we'll see we've got to our comparison now. It's comparing R12, which is currently equal to 1. It's comparing it to 539, which is leet, and so we'll continue. The second time we're going to press the green button, so we were multiplying it there. We were doing 1 times 1, now we've got 2. Now we're going to do 2 times 2 plus 1, and you can see this has got the last value there, so it's comparing it to leet, and again we'll hit continue. We now want to do the red button, so we're going to end up with 10. See, it's 5 from the last time, but we're going to do the red button again, which will be giving us 20. You can see here it's showing up in hex, but we can always just check with R12 if we want to print it as an integer. And now we want to do the green button, so we're going to do the green button 3 times, continue, continue, the third time, And now we're going to do the red button twice. And continue again. And then finally we'll do the green button. Let's see what this is actually equaling at the moment. So we've got R12 there. R12 is 334. But we just did the red button, which hasn't shown up yet as well. So that's 668, and we're about to do 668 times 2 plus 1, which is going to give us leet. Oh, so we need to continue again. We'll enter that in, and now it's not showing up yet. We're going to need to continue and enter something else in here. We don't actually know exactly what we're entering in, so I'm going to say test, and you'll see we've got to our comparison. It's compared R12 to leet. Let's have a look. PR12, and we'll see it's currently equal to leet. So now if we go into next from here, it's now going to perform some jumps. We want to get down and have a look at this string compare, and you'll see it's compared the test that we entered to Bananarama, which didn't match in this case. So if we continue, we get, you're speaking nonsense, cut that out, let's try that again. Bananarama, and we'll hit continue, and you'll see that for some reason a flag popped out of the wall. You walk closer to read it, and then we've got the fake flag because I have the flag already, fake flags in our directory. So we've got that solved manually. Let's jump over to the PwnTools script which I set up. This is just using the PwnTools template, which I have on GitHub and I've covered in most of the videos, where essentially we can just open it up quite easily with GDB and pass in our breakpoints and things here. You can see that I had a breakpoint set up for testing, and then if we pass in GDB, then it'll just launch the program. It'll set up a breakpoint at this offset from the Pi base, and then stop every time we get to that address. We've got the context level set to info here. Let me change that to debug so we get a bit more information. And essentially we go through here. We want to set, let's close that down. We want to set bvar1 equal to false, so we do that by picking up the snake and throwing it at KMH. We want to set ivar7 to 1, and we do that by prying the bars open. We want to get into the code blocks. We had to look around after that. If you remember, it was the number 2, and then we need to make ivar7 equals leet. So I just have here what the red button and the green button do, and we're just looping through in the order that we need in order to make that equal leet. And then we send in this Bananarama password as the password, basically, to get the flag. Receive a couple of lines of junk, and then the next line that we get is going to be our flag. So if we try and run that, Python exploits, you see we've got a lot of debugging, seeing every time it sends and receives something, and then at the end we get our flag back. So that's cool. Now, because we're using this script and we have this method that we can just pass in remote and GDB commands into, we can, let me set this to info, get rid of some of the noise, and then we can just go straight to the server, get the address that we're interested in, the address and the port, and then we can run the same command again, Python exploit, but pass in the server and the port, and you'll see, oh, I was wondering what was going on there. We just need to pass in remote as a keyword, and then it'll run it against the remote server on that port, and taking a little bit longer to get back, but eventually we get back our flag. And that's been the jailbreak challenge. Maybe hopefully get some more of these done, although I want to take a look at the web section as well so you can get some challenges done there.